define the term abstract data type. Abstract data type is a data structure with a set of functions. Set of functions to manage it, or set of functions to manipulate it. Manage/manipulate. Alright. Explain how a stack ADT is implemented. That's easy. You create an array and a variable called top to keep track of what is in the stack. Yep, array and a variable. I think you had to mention push and pop functions. Yeah, you gotta put push and pop functions inside. Alright, explain how the stack ADT is implemented. Alright, a certain element is at the bottom of a stack. Write an algorithm to remove the element from the stack, leaving all the other elements in their same relative positions. You may use appropriate auxiliary structures in your solution. This auxiliary structure is basically a queue. Because you can't use a stack if you pass stack. Yeah, you could use a stack, you know. But just pop everything from the stack and push it to the next stack. Take out the one you want and then pop everything back. Yeah, you could use two stacks. Two stacks could work. The algorithm for it will be you'll have stack 1 and stack 2 with like, I don't know, 10 things in it. So we have stack 1 and stack 2, both of them have 10 stuff in it, 10 things in it. And then you would say while is empty, stack 1 is not equal to 0. So while it's not empty, or you say is equal to 1, whichever one you want to do, while it's not equal to 0, you want to pop from stack 1. You need to push into stack 2 whatever you pop from stack 1. But we can't use is empty as the code. Because if we're trying to get to the last item in stack 1, basically what you're trying to do is you're trying to get to, let's say, 1, 9, and 5, and 4. You basically want to stop at 4, so this is where top is equal to 0. Yeah. So our condition is really to check for while top 1 is not equal to 0. Yeah. So while it's not equal to 0, just keep throwing things out at it. Do push to stack 2 what you popped from stack 1. Right, so you're pushing to stack 2 what you popped from stack 1. That'll keep going on and on and on and on and on and on. Where do they want us to put the variable that we get? To remove the element from the stack. So we'll put what? Integer number is equal to stack 1 num is equal to stack 1 location top, and then top location top 1, and then top 1 minus minus. Right, so we basically empty all the stack there, and then we want to throw everything back inside the stack. So while while is empty in stack 2 is not equal to 0, we want to push into stack 1 what we popped from stack 2, and that will put it back in order. I believe all logic is sound there. How much marks this was? 8 marks? Yeah, that looked like an 8-mark question there. Assume that a queue is implemented in a circular fashion in the state indicated in the diagram below. Alright, cool. Draw a diagram showing the queue after the letters L and Y are inserted. Okay, draw a diagram showing how the queue will look after. Okay, so we have the circular queue, and the circular queue has, well, an empty space here, empty space at the end. The head is there and the tail is there. So obviously it's supposed to look back. Draw a diagram showing the queue after the letters L and Y are inserted. 3 letters are removed and the letters E and Z are then inserted. So they say draw a diagram. I guess it's just one diagram you need. You don't need to show the process. Who needs the process? This is one of them things that you can just kind of be like, alright, is either get it correct or not. I guess if you show the process, you'll get so many marks as you go along. So it might be better to show the process by one diagram after another, because usually when they give questions like this, they'll ask you to show the diagram after each step. But in this case, they ain't really looking for that now. So let me see what will happen here. So the letters L and Y are inserted. So when you insert L and Y, what's gonna happen? The L gonna go here, and then the Y gonna go there. 3 letters are removed. So they're gonna remove the Q, the L, and the M. And then the letters E and Z are inserted. So we're gonna put a E here and a Z here, but this spot here will stay blank because that was where the M was. So we'll have the O, C, R, D, S, and F. E's, yeah, like it's like E. What would have happened is the E and the Z. What would happen is that the tail would have been here, and the head would have been up here. Because when you take out the Q, the L, and the M, the head would have ended up moving from here to here to here to here, right? So that'll be the head. So once the head moves to there, when you're adding something to a Q, you just add at the end. So basically what you will be adding is at the tail. So the tail will go up and then enter the E, and then the tail will go up again and then enter the Z. And this will be the new tail here. Because it's a circular queue, it's recycle the spaces. Alright, describe how you would sort an array of n items using a bubble sort. So this is describing a bubble sort. Okay. Step 1 of a bubble sort would be to, when you have to describe it, you have to describe first pass and second pass kind of thing, right? So you'll have to create a loop that will do a first pass through all the locations of the array. Then every time it passes, it should compare adjacent numbers, and if the numbers need to be swapped, then swap them. And third, repeat this process until the smallest number is at the end, and keep passing until all numbers have been compared. Yeah, it's kind of weird what they want. Yeah. Here the examiner's reporter. The quality of the responses in Part D was also generally poor. It seems that the majority of candidates did not have a clear understanding of the bubble sort algorithm. Several candidates described the first pass correctly, but did not go on to explain what happens after the first pass. They simply concluded their responses by saying that the algorithm is repeated until the entire array is in sorted order. But getting the array in sorted order is the purpose of the sort algorithm in the first place. Some candidates wrote C code in their responses, however, the question did not require the writing of C code. So I find it very unreasonable to be asking people to explain what a sort does do. At least the worst case that they could do is actually to write an algorithm for it or draw it out or something. But to explain it, they just want words to read. They just want, they like to read stuff, apparently. So yeah, that's that there. That last part there was slightly annoying, but we're good going. Alright, so let me draw the linked list first and see how the explanation will fit. Alright, so you must start off with a why is it blue? That's supposed to be blue. Alright, so you're drawing a train, right? You're drawing a train. Box. Pointer. To the next box. Pointer. To the next box. And this one here must go down to ground. And the this one here we call it head. If you want, you could spice it up and put little numbers inside, but you don't really need to. And then now the linked list is going to be, it is a set of nodes that point to each other in a list / sequential format, with the last node pointing to null. We good there? Alright, did you have that? Well, the explanation part is the hard part. Did you explain it similar to that?
No, but I know now.
Okay. I find the explanation for it is difficult to do also, because it's like, what do you really want me to say? So yeah, one of the key things is it must point to null at the end, and it's a bunch of nodes that point to each other in a sequential format. That's basically it. Alright, part B. Consider the following array ARR 3, 12, 9, right? Write a C program to store and then sort the values using a simple selection sort. Oh man, this is easy. And yeah, a selection sort is, oh no, a selection sort, no, selection sort not that straightforward. Alright, so we have to store the values and then sort the values using a simple selection sort. Yeah. Nah, this could give some trouble. Especially if you can't remember code.
Haha.
Just needed to throw that in there. But at least remember that you need 2 for loops. If you have 2 for loops, you can get like probably 8 to 10 of the marks without nailing it totally. But remembering how to do a selection sort, you gotta cram that. I'm not too sure if remembering selection sort is the most important thing. It might be better off remembering the stacks and queues code, because that will be more than likely what they ask for a lot. I don't think I ever see sorts and switches. I don't think they really ask that much. But alright, let's let go. Store the values and then sort the values. So do I have to store those actual numbers? Yes. So okay, to store the values, we'll just say int ARR 6, 0 to 5 is 6, equal to 3, 12, 9, 10, 5, and 4. Alright, so that's some brownie points there. I guess get those marks and say thanks. I guess again a mark for doing that. Should be. Right, so now we want to sort through the values. The problem is in a selection sort, you have to do a swap. So we're going to assume that the swap is there already, which is usually, sometimes you'll have any question, please state any assumptions I make, but whatever. So there is an inner loop and there's an outer loop. So we have int, I and j are the normal loops that I normally use. So I would be the outer loop and j would be the inner loop. And then you have min ID, minimum ID, right? And from there you have to do your outer loop. Now your outer loop, you're going to try to go to the to this location here, because our selection sort can't go straight up to the end, because then it'll have nothing to compare to. So it's normally go up to the no, it's go straight up to the end, is the whatever the size is. So because we know the size of this is 6, we go into location 5, right? Cool, yeah. So we're saying for alright, so we're saying right good. So we're saying for, I had to create a C also. For C is equal to 0, C less than 6, C++. That way we will go all the way up to location 5. And then we have to keep track of the location of the minimum. So we have to say min ID is equal to C. Oh, I use C instead of, I was supposed to use I, my bad. I saw custom using C for counter. Let's change this to C. That'll save more trouble. right here. So min ID is equal to C. That means we starting off with the minimum ID is at this location here, right? And then after we keep track of that minimum ID, what I want to do now is create a next for loop, and I want to jump through all the locations to do the comparison. So I'm now going to say J is equal to C plus 1. That's where I'm going to start, because I want to now start by this location here, because I want to compare these two. And this is the arrow that's going to actually do the jumping. And each time it jumps, it's going to be comparing with this guy here, but that one there. So C is equal to J plus 1, and I'm going to J less than 6, and I'm going to go up J plus plus. Right, so now that I have that loop going, what do I want to do? I want to say if the variable, the thing at ARR location J, which is inside this loop, is less than the variable at ARR location min ID, right? So we're comparing what is here and what is here. If it is less than it, then I want to swap. No, I'm not swapping. I'm updating min ID. Min ID is now equal to the location that I'm at right now. So in essence, it will keep track of the tree and say, okay, cool, this is our first lowest value, and then we go and check here and see if this is lower. If this is lower, then update this one as the one that we're keeping track of. If this is lower, keep track of that one. If this is lower, keep track of that one. If this one is lower, keep track of that one. Keep track. So by updating min ID, I am keeping track of what is happening. I have run out of space. That's not how to get this whole thing to fit, or else it will be all in vain. Right, go up here. See if it'll fit there. Yeah, close enough, right? Alright, so updating min ID, and when I'm done, this whole for loop will loop through the whole sequence like that, and update whatever the min ID is, and then I'm going to swap. In ARR location min ID, the value there with ARR location I, and then yeah, that's it. Can't see any other problem there. That's it there. Okay, any questions?
No.
All right, where did you mess up?
I read the question.
Okay, that's a good sign.
Well, I didn't see why they asked to store the values in the array. To store the values in the array. I mean, I understand now what they meant, but I misinterpreted it when I read it the first time.
Yeah, that was like brownie marks that they just kind of give it to be like, all right, let's give them all 1 mark to start with. So you get 1 mark here. You get 1 mark for declaring the variables. You get 1 mark for carrying this loop up to the right spot. It's 12 marks, so they probably, you'll get a mark for the for and they get a mark for the condition. This thing's supposed to go up to I think this number here is supposed to be up to 5, Yeah, the first part of the loop, the first loop, supposed to go up to the penultimate value in location in the array. Because if you go up straight to the end, you will end up having a problem because you have nothing to compare to when you do the C+1 down here. So you gotta go up to 5 there. Yeah, so C less than 5. Yeah, so go up to location 4. Right, yeah, good. So that'll be the one mark there. And then we're going to do keep track of the minimum ID, which will be C. You get 2 marks for this for loop here. If the location that you have with the min ID is less, good. Update the min ID if it's necessary, and then at the end you swap it. You're swapping the value that is in min ID with the value that's inside location I. Yeah, the swap will take place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 will be the next mark, right?
Maybe they give a mark for each variable.
Okay. I'll just put the custom mark. That's probably neatness and indentation. But so when you're doing this question, it's very possible that you may not remember how to code it, but you must at least remember that there are 2 loops, right? So if you could get,
How are going to help?
if you write down 2 for loops inside, they have to give you the marks. Like if you write down a for loop that goes from one for loop with like I and the next for loop with J, you'll get 4 marks. Well, unless you put the wrong number. So put 2 for loops with the size of the array, and that will save you. That'll set you above the rest. And you have to do a comparison. So if you just write the word if, hopefully, you might get a mark there too. So this question, you could get 6 marks just for, you could get a mark for here for the 1. For declaring the array and filling it up. You get a mark for creating variables. Then you can get a mark for 4 here, a mark for 4 there, and a mark for if. So 1, 2, 3, and then putting the values inside the for item. You probably would not get a C+1. 1, 2, 3, 4. You could get 5 marks in this question by just writing crap. Alright, explain what is involved in a linear search and a binary search. Alright, so a linear search will checks each location of the array and compares it with the search value. If it is correct, if it is a match, the search gives a positive message. Yes, for the use. Positive message, right? Binary search now. Part 2, which is binary search now. Binary search finds the midpoint. When it finds the midpoint, it's going to check to see if the number is higher or lower. Checks to see if the search value is higher or lower. Value is higher or lower, and then splits the array in half and focuses on the half that has the number, then repeats. That was not what I wanted to do. Then it repeats until a match. Yeah. Right, 4 marks to the binary search because you have to include that it's split anything in half. If you don't include that, then you'll have a problem. Explain what is involved. Involved, does it mean that you have to sort it first? Let me see. Normally they would ask you what is the prerequisite for a binary search. That's the process. Now the process will just go through each one and find it. But it would be wise to put first it must be sorted, because that is definitely necessary. Okay, cool. Alright, so that should be it for that.